Okay, so I'm asked to integrate this, the area R, and this is my xy axes. So what I'm going to do is I have my double integral over the region R of my function. It's right there, so I have negative 2x minus 2y plus 5 dA. Okay, so now I need to figure out how I'm going to set this up. Now looking here, I have this line that is bounded by, so I can't just go, my integral can't just be from 0 to 1 and for the x's and from 0 to 1 for the y's, because it's not a perfect rectangle, or square in this case. So what I'm going to do is I'm going to integrate from all of the y values from 0 and count all these random numbers that are going to pop up using this equation that y equals 1 minus x anywhere along this line. So that's how I'm going to set up my y values. I'm going to do that first. So I have from 0 to 1 minus x minus 2x minus 2y plus 5 dA. Oh, actually that's going to be dy, sorry. I'm doing y first, and then I'm going to do x next. Okay, and then, so I have all of those areas. I'm going to be splitting it up like that, and then I can just add all of those spots up using my x values. Okay. So now I can integrate this. I have integral from 0 to 1 of, integrating in terms of y, I have negative 2xy minus 2y squared over 2 plus 5y from 0 to 1 minus x dx. Okay, now I have to plug in all these values. I have integral from 0 to 1 of negative 2x times 1 minus x, because that's what y is, and this cancels out to 1, minus 1 minus x squared plus 5 times 1 minus x. Minus, now when I plug in 0 here, they all have a y, so this is going to all cancel out to 0. dx. Okay. So now I can just multiply all of this out. I get the integral from 0 to 1 of negative 2x plus 2x squared minus, flowing that out, I have 1 minus 2x plus x squared plus 5 minus 5x dx. Okay. And then I'm going to continue to add like terms. I make the integral of 0 to 1 of x squared minus 5x plus 4 dx. Now I'm going to integrate in terms of x. So that's going to give me x cubed 1/3 minus 5x squared over 2 plus 4x, sorry about the dog, from 0 to 1. Okay, now I'm going to plug in all these values, and then I get, plugging in 1, I have 1 over 3 minus 5 over 2 plus 4. And then when I plug in the 0 values for the x, that's all going to be 0. Okay, so now I need to add all of these. And I'm going to let the LCD be 6. So this is going to equal, I have to times that by 2. By 2, I get 2 over 6 minus, times it by 3, 15 over 6 plus, got to times that by 6, 24 over 6. Okay. And then, and you add all that up, you'll get your answer. 11 over 6.